The next special form we're going to meet is the special form a squared minus b squared. What is this? Notice this is not a perfect square because perfect squares have middle terms. But looking at this, we would certainly hope, wouldn't we, that a minus b would be a factor. Right? What else would we have to have? To get a squared, we would need to multiply a times a. But then we would multiply a times negative b and get negative ab. If we've got a negative ab, though, we would have to get a positive ab because there's no ab here. What do we need to multiply a by to get a positive ab? Oh, a positive b. Positive b times negative b is in fact negative b squared. So in fact this does factor. It factors as a minus b times a plus b. And that's really nifty, right? Because this actually gives us a way to factor a binomial. How can we tell if we have a difference of squares on our hands? Well, it's actually super easy. We have a difference of squares if we're looking at a binomial. The operation is subtraction, not addition. And each term is a perfect square. So, for example, this binomial, noting that 25x to the sixth, that's 5x cubed squared, and 36z squared, that's 6z all squared. Noticing that, this is a difference of squares. So it factors as 5x cubed minus 6z times 5x cubed plus 6z. I'm going to have you do one of these. Factor 4x squared minus 121y squared. Pause the video and try this now. You may have needed to put 121 into your calculator to see that it was a perfect square. But we see that this is x all squared minus 11y all squared. And so this factors as a difference of squares, 4x minus 11y times 4x plus 11y.